So, okay, so the statement that we're going to apply, yeah? I'm not going to write this again.
Combi.
Okay.
Combi, no.
Is if you have a polynomial in n variables, yeah? I don't know if you watched it last week, but yeah, if you have a polynomial in n variables, yeah? And its degree can be written as, so this is maybe where the combi comes in. A sum of the ti's, yeah? One for each variable, yeah? And the degree can be realized by a term of this form. Yeah? Okay. Okay. Does that make sense? And you have these SIs, so it's basically some values to put into these variables. So these values are inside the coefficient field. If there's more of these SIs than the TIs, yeah? Okay. The conclusion is that F is non-zero on some S's. Okay. So unfortunately, you missed the proof of this, but maybe we can catch it up at some point. Okay. And obviously, it's harder to remember the statement of it if you don't understand what is going on. But like, basically, the reason I guess it's combi is you're only really dealing with the numbers of like the degrees and stuff. You don't actually care about the algebra much. So it's like if you have a bunch of subsets, right? Okay. And there's enough of them, okay? Then because f is not zero, right? Because f has a big degree, it can't be a zero polynomial. So then it can't be zero on something, basically. This is kind of like the maximally paraphrased version of this. Yeah. Like if it's zero on a lot of stuff, then it should be the zero polynomial, basically, right? Okay. But if you know it's not the zero polynomial, then it can't be zero on a lot of stuff. Yeah. Okay. So we're at the part where we're looking just trying to solve examples of this. Yeah. Okay, so maybe this will help you understand it. So application number 1. Oh, actually, this is it sounds kind of weird as well. So maybe it'll help you understand the thing. So if you take f to be integers mod p, yeah. So it's like 0 up to p minus 1. That's a field, okay? So and then you have these polynomials p, p1, and they have n variables, yeah, up to pm, yeah.
Are these p polynomials?
Yeah, and n variables, okay. And there's a lot more variables than the degrees of the p's, okay. N is bigger than the sum of the degrees of the p's, yeah. Okay. And suppose there's a common 0 to all the p's, yeah. So p of I of some c is equal to 0 for all I. Yeah. Okay. Then the conclusion is there's another common 0 to all the p's. Okay.
What's that end?
Yeah, and I'm gonna read. Maybe I'll read a little bit of the history of this problem to you while you're thinking about what this means. So, there exists maybe a D or a C prime not equal to C, such that Pi of C prime is equal to 0 for all. So if there's a common 0, there's another common 0. Let me just look at this history.
When you say C, is that like?
Yeah, C is like a tuple,
Wait, hold on.
Yeah. Okay.
So n greater than. So n sum of the degrees. Pi. It's not really. Wait, it's like.
Yeah, so apparently this is a theorem conjectured by Artin. Have you heard of Artin? You hear of these guys eventually. They just do everything. So
Oh yeah, it's
1934.
What?
Oh yeah, we should mention that this paper we're reading this basically came out of this paper, this Combinatorial, 1999, and it made it kind of made the IMO meta around 2010.
It disappeared.
Yeah. Okay. Anyway, so
Wait, are we like placing?
so Artin conjectured this thing here, yeah. In 1934. And was proved by Chevalley in 1935. So it didn't survive long.
And then reproven by this guy.
Alon. And extended by warning in. So this is, I guess this is called the Chevalley warning theorem or something. In 1935 as well, yeah. Yeah, so the proof extends to arbitrary finite fields, but let's just take, for example, this.
Should we close this door?
Yes, thanks. Mod P. Okay, if you wanted something to drink or eat, Lisa, Crystal, 你记得他吧？
记得。那果汁吗？
果汁、水，说随便都可以。
不要啦。
Yes, she says yes.
我知道。
会自己来啊，你习惯了就是可以自己倒的。
对，be at home, pretend you're at home.
Example A.
Huh?
Example A right behind you.
Oh yeah. If you were here to see what Lucas did, you would have no problems pretending you're at home.
Do not question. It is beautiful.
He's gonna make another.
It does. It becomes the real
开始吃小孩的零食了啊。
It is infused.
Oh, the irony! We're using a chair as a table.
Oh.
All right. Are we all like on board with this?
Yes. I understand. For once.
Okay. So. Yeah. So
basically S. Now we have like S is greater than condition S is greater than the TI.
Yeah. So actually, the first step is actually pretty OP. It's just okay. Well, if you know you're gonna use a theorem, right?
Yeah.
You have to define F.
Yeah.
Right.
F is
that.
F has to satisfy these things, right? Whatever that is.
Yeah.
Okay. So
wait,
F.
Wait. All your X's from like the big F.
All the what?
Where does the big F is the
Why is there
Z
small
mod P coming?
Small left.
Oh, it hasn't come in yet.
Like in the problem statement.
Field here.
In the problem statement.
Yeah.
Oh, I guess the C's are. I mean,
Like all the X's are just that are from.
like the values they can take. Yeah. So
Yeah,
when you're subbing in values, like the C, right? You're subbing in is a tuple of these CIs, right?
And they're all.
And each one is like Z mod P. And then when it equals 0, you're actually adding the mod P. You're not like, you know what I mean? Like everything's happening mod P.
Okay.
Yeah.
Oh, so it's congruent to 0. Okay.
If you like, yeah.
Okay.
No?
It doesn't actually need to be 0.
Okay, check this out. OP 1 minus PI, yeah, to the power of P minus 1. Just the prime, yeah?
Fermat's little theorem.
Yeah. Recall Fermat's little theorem. Okay.
Oh. Damn.
Oh.
Wait, hold up.
So now that's 0.
Minus.
Delta.
Oh my.
Fake project.
So let me just double product.
What the?
But that, but each thing is easy. It's just xj minus c.
So it's like a combination. Wow,
Oh,
combination.
wait.
J
What does that even mean?
J,
C is
J goes from 1 to n.
Why is there a random not filled in correct?
Wait. C is Wait, what like?
Is C the C that's
What's C? Yeah.
Oh.
C is like set, right?
Oh yeah, I think there's a different notation here. Hold on.
Bro.
Let's see what it surely it looks comical in the
Yeah, let's not call this C, yeah. Let's just call that straight up this, yeah. Yeah.
Ah. Okay.
uh,
Wait,
What
so
am I
now
inviting?
you put in CI.
Yeah, so this is just just a single value, yeah. Whereas that C was like a tuple, yeah.
so every value of C.
So which C is this now?
So this is a single value, yeah. So it's C is not equal to CJ. And it runs through all the values otherwise. So C is in Z mod P.
Oh.
Yeah. So there should be P minus 1.
Yeah.
Wait. Okay,
wait.
there's already P minus 1 is the size of the field, yeah? Oh no.
Wait,
P is the size of the field, yeah?
No,
And P minus 1 things in that product.
Wait, does that mean
You take all the values except for the J, right? And J is the jth entry of that tuple, yeah?
Yeah. I'll say you don't get a 0 otherwise. Otherwise you get 0.
Yeah. But
Yeah.
not necessarily.
Yeah,
You can still get 0.
You will. Yeah, but like,
Oh wait, hold up.
you right now definitely. You won't definitely get 0.
Okay, so I guess what are the conditions of the theorem? You got this F, right? It's got to be it's got to have these degree
Yes.
right terms, yeah?
They're all P minus 1.
Yeah.
And then you subtract the P minus 1.
So I guess if you sub in the C1, C tuple, right? This might not obviously be 0, yeah?
No.
Yeah.
Okay, well we don't even know what delta is, yeah?
Yeah.
Okay.
Just like scalar.
It's a scalar, yeah. Delta is the only thing we don't know what it is, yeah? But we pick delta, right? Such that this is equal to 0, yeah? So delta is defined by the condition f of C1
Equals 0.
Cn equals 0.
Oh.
Okay?
And then
And
you find another one.
so the important thing about delta is if we can try to see it, is delta is not 0. Okay?
So we've got to find 2 deltas.
It's not 0.
So basically what you have to show, if for example, if delta was 0, right?
Yeah.
That meant like this part was already 0 when you subbed in the C's, right?
Yeah.
But, well,
no, it's 1 because when you sub in the C, P of I is 0.
yeah, it's a P of I is 0 when you sub in the C's, right? So if that's 0, and 0 to the P minus 1 is 0, then that's just 1, right? So it's non-zero when you sub in the c there. So there has to be something here to make it 0, right? And delta is whatever it is to make it 0.
So there's one delta that must exist.
Yeah, and this thing next to the delta is not 0, right? Because it's avoiding the CJ. Yeah.
Yes.
If it had the CJ, then it'd be 0, and you couldn't choose delta to do anything anyway, right? But this thing's non-zero, so you can subtract an amount to make it 0. Yeah. Okay. So obviously, this first step didn't come as suddenly as it came for us. Yeah. It may have taken some thought, but like when you're reading, it's like boom, have the universe on your plate. Okay. So argument by contradiction. Okay. Yeah. Assume that there is no other 0. Yeah. So assume it's the only common 0. Yeah. So that means there's some. So if you sub in. So if you sub in stuff, right, then there's going to be some pi which is not 0 on things. Because if all the pi's were 0 on stuff, there'd be another common 0, right? So there's no common 0. No matter what you subbed in, there'd be some pi that wasn't 0. Right? But if it wasn't 0, right?
Then that's not 0.
Then Fermat's little theorem says that part's 0. Because that factor gives you a 1, right? 1 minus 1. Yeah?
Yes.
And then that becomes 0.
So that becomes 0.
So now you just need that part to become 0 as well.
Yeah. So okay, well remember we're trying to use the theorem here, right?
Yeah.
So we need the f to have. So how does use the theorem? It's basically you pick an f, right? Well, spectacular choice of f. For this f to work, you need to be able to partition the degree, right? So you need to find the TIs in such a way that that term exists. Okay.
Yeah. And that's also the degree.
Yeah. So I think in this case, do we just take the s's just to be the whole set? For example, we could take, because these s's have to be finite sets, right? We could actually just take all the s's to be, and let's see if it works. You could take all the si's to actually just be the whole set. Yeah.
Ooh. Oh yeah, fair enough.
Degree.
Well, with SI is equal to the size of SI is P.
The size of SI is P, right? So we need. So what's the degree of F actually?
Degree of F.
Degree of F. Degree of F is
Oh
wait, didn't we find it before?
Oh yeah. We can kind of figure it out, right?
We found it before.
Yeah, I think the condition helps. So what's the degree of? Let me start a different color now. What's the degree of this term? Like this term.
Oh.
It should be easy to count, right?
N times P minus 1.
Yeah. N times P minus 1, right?
Yes.
What's the degree of this term?
That would be M. There's M of these, and then M times P. The degree of Pi to the power of P minus 1. Wait, no.
Not to the power.
Oh, just times P minus 1 times M.
So P minus 1
times M.
degree of Pi. Wait, are you timesing by M?
I think so. You have to sum by
Sum, yeah.
Sum, yeah. Oops.
Right. Does this remind you of anything?
Oh wait. Wait, hold up. Oh wait, is it like F and J? GI and F. Wait.
It's something much more recent. Obviously, after Crystal got here, it's not gonna remind you of anything before she got here.
Oh.
Well,
A little zero.
not obviously by maths, but obviously by psychology of me.
Lemma 0.
Maybe Leo needs to eat some cereal too.
Leo juice activation.
Period.
Oh, I actually have chocolate, but then I don't know if I should.
Yes.
什么？
应该把那个巧克力拿过来。
对吧？
Put the chocolate in the cereal as well.
No, this is
干嘛？
what's happening.
那等一下，我拿吧。
If it's all p minus 1, p minus 1, how do you degree? Oh wait, this is like the sum ti. Brain not working. Damn.
I'm trying.
要把那个装好。
I finally get my C.
Oh wait, a minute, hold up. Are they like in this equal or something? What's the condition? We had something for n, I'm pretty sure.
Oh, okay, so Will's starting to get it. Okay.
我
So,
们还会吃水果呢，给你们洗葡萄。
可以啊，先吃水果。
So do I get my
Eat
cereal
fruit.
now?
Eat fruit first.
We don't understand.
Eat fruit so that you're not just eating sugar for the sake of eating sugar.
Wait, what are you eating?
What are you eating? Sugar for the
Oh,
sake
yeah, that's yours, bud. Yeah. So
So
look at the condition.
Yeah.
N is greater than the sum of the degrees, right?
Oh, so they equal. Wait. Are they,
So the degree is n times
Degree,
p minus 1.
N is bigger, yeah?
Yeah, that's bigger. Yeah. And then that looks familiar.
Does that make sense?
Yes.
Oh, and then you get S and T.
Yeah, so the degree is bigger, right? So that means the degree is just n times p minus 1.
Yeah.
Yeah? Because you got less stuff here, you don't care about that when you look at the degree, yeah? Are we on the same page here?
Yes.
So the degree of f is equal to n times p minus 1, yeah? Okay, so now we want to partition f into n things, right? Well, we have n p minus 1s, yeah? So we could write it as p minus 1 n times, yeah? And each, so what we need for this to work is we need an x1 to the power of p minus 1, right? And x2 to the power of p minus 1. Up to xn to the p minus 1, yeah? We need that to exist.
So that's just your thing.
And p minus 1 is obviously less than s, right? Which s is p, yeah?
Yeah.
So p minus 1 is less than p, which is equal to the size of s. Yeah?
Okay.
So,
Oh, wait, and then, like, well, you do have that term, right? That's just your delta, you're leaving delta.
is it?
Isn't it?
Um,
Can you have, like, oh, wait.
oh, is it just by design that?
Yeah.
And delta is not 0, right?
Yeah.
So if delta is not, so delta is the coefficient of this, is it?
Delta, yeah, delta is not.
Delta, yeah.
Oh.
Oh. I'm gonna try that and fail.
Oh no. I'm not touching that. Yeah.
What?
You touch
You
that.
can have it.
Fine.
I will.
2 for 2.
It's so
You dropped on the floor.
2 for 2.
How did he do it?
I've thrown it like as high as C block. I called it C block. Yeah. Oh my goodness.
Oh, it's an inside reference.
Oh. Two stories.
然后我总感觉他们会把这个椅子踢翻了，然后水就洒。
Wow,
We're very responsible.
she had a vision that you guys will somehow manage to
感觉
topple
奶奶
the
走
seat
路挺可怕的
and。 spill the. Can you guys like not travel past the seat anymore? Either that or Crystal needs to drink it faster.
Make yourself feel at home.
Okay.
3 for 3.
Does this make sense?
One.
Yeah. So it satisfies.
Oh,
So wait, let's have. Are we agreed that the term has a non-zero coefficient?
Yes.
So is it clear that the coefficient of this monomial, yeah, x1, so it's basically the product of the variables to the power of p minus 1, yeah? Its coefficient is delta. Yeah? Or minus delta. Alright, anyway, so but then minus delta is not 0 because delta is not 0, right? So we satisfied the conditions for the magical theorem, yeah? That makes sense?
And then we apply the magical theorem.
So now the test is to remember the conclusion of the magical theorem.
It's non-zero.
the magical?
Oh gosh.
Wait, give me the name.
Neither theorem, neither assumption nor conclusion is remembered.
What?
Wait, tell me.
It's like, where am I?
Is it theorem 0, 1, or 2? It's 2, right?
Theorem, yeah, the
So
assumption
it's
is
not even 0. It's non-zero.
Okay.
I don't remember the conclusion.
Hold on. So f is not 0 for something, right?
That's incredible.
And since we took S to be everything, it's just saying it's non-zero for something, yeah?
Everything. Wait, everything or something.
Huh?
Something is everything. Everything is something.
It's non-zero.
I'm gonna put all my dead
So F is non-zero for something, right? Yeah.
But your something is the whole thing.
Oh no, it's something in there. Yeah. And so and that thing in there is it's in and the thing is the whole thing. So it's literally just non-zero on something.
I'm at 3.
So
If I eat it, I'm
so actually you
gonna
got to be careful when you're doing finite fields, like
Already.
a polynomial could be 0 on everything and still basically be a non-zero polynomial, like x to the p minus 1 minus 1 is like, well, and then times x or something times x, that's like 0 literally on everything, right? But it's non-zero as a polynomial. So that's why, like, you got to differentiate between the concept of a polynomial and polynomial function. Yeah. But as a function, it's a 0 function, right? But as a polynomial, it's like x times x to the p minus 1 minus 1. Yeah.
Got to differentiate.
Okay. Can you see what happens now?
Nearly.
Apply the magical theorem.
Apply theorem. So now that's non-zero for something.
Yeah.
And that's a contradiction.
Yeah.
That is supposed to be a contradiction.
I'm pretty sure that's what we say. What are you doing,
Yeah.
bum?
Why is that a contradiction?
Because that means it's a 0 for another thing. And if it's. Wait, hold on. Hold on. Wait, that means that's 0, right? I was like, wait, shit.
So you put the non-zero thing.
It'd be cool if it's like your touch screen, you just draw on it.
It's somehow a contradiction.
You take the something and plug it in, I'm assuming.
But oh wait, what is that?
Yeah, so can you see, okay, F is literally 0 on everything.
Huh?
Okay. So for it to not be 0 on something, it's already like a contradiction.
Why is it 0 on it?
Because remember what happened to F, right? When you sub in anything at all, right?
Yeah.
So if you sub in the 0 if you sub in the original 0, it's 0, right? Yeah.
If you sub in the original 0, it's 0.
Because it's just 0, right?
Yeah.
Delta is defined, so that's 0,
Yeah,
right?
yeah.
Okay. So that's something that's obviously 0.
Yep.
If you sub in anything else, right?
Yeah, your
Because
first copy.
the first part becomes 0, right?
Yeah.
But look at how the second part's defined. It's literally x minus everything.
X minus.
So like if you literally sub in anything on the second part, right? Like
It'll be
like x minus, you know what I mean?
Okay, so you have to sub in something. So then.
Yeah,
xj minus c.
it'll be 0 for something, right? Yeah. So as long as you don't put in cj, right? You can put cj plus 1, right? But c is ranges C plus 1 is in there.
Basically, as long as you don't put in your C1 to Cn again,
Yeah,
you'll get 0 again.
yeah. So as long as you don't put like even parts of it.
Oh,
is-
but it's
yeah.
non-zero contradiction at all. Wow.
Excellent.
Good.
Excellent. And I think this. Well, I guess one of the things like I guess we haven't really looked up. We haven't really looked up the proof of Artin
Wait,
or Chevalley.
When it says it's non-zero on something, but what if that something is just C1 to Cn?
Oh no, it's by definition 0 on C1 to Cn.
Yeah.
That's still a contradiction.
Huh?
It's 0 on
Oh,
everything. Yeah.
Oh wait, and then you'll. But it's not 0 on anything because you have that thing. So
Yeah.
it's not bad.
Yeah. The theorem says it's not 0 on something, right?
But you know it's.
But it's 0 on everything. Yeah. Yeah, so if we maybe one day we can look up the papers of Chevalley and Artin, and they're probably like very long. Maybe they're not that long, but like for the proof to turn into something this short, right? That's one of the sort of achievements of this theorem, I guess, and that's why when people maybe there's also a bit of like maybe a cinematic effect to kind of maybe also maybe make it look a bit more elegant than it is. You just spam F satisfies theorem and then you're done. Okay. Any questions about this?
We are also.
So we maybe just have time for one more before your mentoring thing starts then.
Yes.
Ah,
man,
and
we
like
have
that
to go there.